Now, something that we'll be asked to do as well is to work with domains, ranges, and then from there find inverses. And looks like the book starts off pretty loosely, referring to things specifically as an inverse rather than as an inverse function, because for an inverse function to happen, we have to meet a certain criteria, and I'll have a look at that a little bit later on. So what you'll be asked to do is you'll be asked to, you'll be given a function with mapping notation like we've got here, and you'll be asked to determine the domain of the function, the range of the function, the domain of the inverse, and the range of the inverse. And we look at the inverse by f to the power -1. And from there you'll be asked to sketch the inverse on the same set of axes, and sometimes you'll be asked to determine domains based on some other information as well. But first we'll have a look at this. So if we have a look at our mapping notation, we've gone from f0 to 3, so that's our domain, 0 to 3, so that's what I'm going to put down. So domain of f is 0 to 3. And then our range, if we were to graph this, we're graphing 2x minus 2, so we're going to start at -2, and we're going to go up on a gradient of 2. Do that again, we're going to go up like that. So here we're at -0 and -2. That's what we're at 0, and because we know it's a 1-to-1, we know it's linear, we're going to go to 3. We substitute 3 into this equation. We'll end up with 2 times 3 minus 2, which gives us 4. So it's going to go up to 3, and 4. So then, based on that, we can see that our range is goes from -2 out to 4, and it goes from -2 out to 4. Now, this is going to be a square bracket because we start with a square bracket, and then it's going to end in a rounded bracket. So, now we have a look at this information we've got here, which tells us that the domain of f of x becomes the range of f minus 1 of x, or the inverse, and that the range of the original function becomes the domain of the inverse. So, to find out the domain of the inverse, we look at our range. So this is just going to be -2 to 4. And our range, we've already got it there. So it's going to be 0 to 3. The 3 needs a rounded bracket. So the bracket's got to line up. So then, from there, you'll also be asked to determine the rule for the inverse, or the inverse function, or the equation, or whatever the wording is. So to do that, what we do is we take our equation and we write it in terms of y. So we write y equals 2x minus 2. And then we swap x and y over, we interchange them. So this becomes x equals 2y minus 2. Now we solve for y. So we bring this 2 over to the other side. So we'll have x plus 2 equals 2y. I'm going to finish it off here. So we've got 2y equals x plus 2. Now we divide both sides by 2. So we'll have y equals 1 over 2x. Draw that clearer. 1 over 2x plus 1. And now if we were to draw that on the same set of axes, we'd have it looking like this. Now it's really important to note that they will cross over here on the line of y equals x. So that's what we've got going on there. So just to recap, whatever you're given, determine the domain, state that, and based on that you work out the range, which we've done here with the linear function. Graph it, because sometimes this won't always work. Well, you can't just substitute this value into the function and have it work. You've got to graph it. And then the domain of f of x becomes a range of the inverse, and the range of the original function becomes the domain of the inverse. So we just swap them over. Then, to find the inverse function, we write it in terms of y. So we say y equals 2x minus 2. We write it in terms of y, interchange x and y, so we just swap them over, and then we solve for y. Now, one thing I forgot to do was to write it in the final notation of f -1 of x. So this tells us the inverse, because there's just y, equals 1 over 2x plus 1. So they're the steps we take.